You guys getting audio?
Yeah.
Okay. Thanks, Savannah. Brooke, are you there?
Yeah.
Awesome. Thank you. Okay, guys, I'm glad you four are here. I want to show you something I'm going to start using. Let me share my screen. Maybe you saw this already if you were in Google Classroom yesterday or today, and maybe you haven't. In our Google Classroom, now I think your guys' view looks just like this when you log in for like the main page. So forgive me if it does look a little different, but there's a stream of information, like postings basically, the stream, and I'm keeping a comment on the stream here with our class meeting link. So if you're having trouble, like if you're searching through your email to find the link for my math class, I've got it in the Google Classroom. And if you accept entry into the Google Classroom, which I've sent you all that invitation, and I can do it again if you need me to. Just let me know. Um, then you just go into Google, click on these 9 dots, click on Classroom, and then boom, oops. Then you'll see your Math 1B class there. That's us. And at the very top of that stream is the link for the class. So just in case you're having trouble with the link and that's ever a problem, I want you to use this. My goal was to make it easier to find class. And then also, I started this thing. I want to start using this in class with all of you, the badge board. Um, so if you click on this link here, you can see our badges. And I'm going to do a new one every unit. So here's unit 6. I made up these first 4 badges, and then there's also a badge for each assignment. So the first 4 I made up are Great Communicator badge, and that means you've joined Remind.com and responds to text. Everyone who's joined would get this. Um, I can send that info to you again. Maybe I should put that on the classroom. If you haven't joined Remind.com, it's the program that I use on the computer. It looks like this, and I can see texts from you guys all day long while I'm working with other students or anything in the afternoon or before our classes start. So it's how I send out announcements. So if I'm going to miss class or just a reminder about a test or something, I'm going to send it to the whole group through Remind. And then you guys can also text me through Remind. So a lot of you have done this, but in case you haven't, if you look through your welcome emails that I sent for like the beginning of the school year and this class, there's a link there and instructions how to join. And if you need help doing that, I'm happy to like send that to you if you want to just write me a Google chat. Google Chat's a good thing to use, but I do want to also use Remind with you guys because I can message all of you through that. So that's the first badge that you can earn by joining Google, by joining myremind.com. So I've got Anaya down, I've got Brooke and Levi's joined, Savannah, Tira, and Victor. So you'll have the Great Communicator badge. And then these 3 in the middle, a lot of you do this already, but I wanted to start fresh today and this week. So a lot of you would have earned this already last week, but I just wanted to give everyone a chance to learn it to get or to earn it together this week. So risk taker is answering a math question in front of the group. If you just answer a question today or tomorrow or Wednesday, then I will give you the risk taker badge and put that on um, your row there. And again, a lot of you already do this, and I really appreciate when you do take a risk and try to answer a question, even if it's not correct. I'm going to give you this badge. I just want to have you engage with me and with the group. The next one is committed. 1 week of perfect attendance. So there's a lot of you who have perfect attendance already, and I really appreciate that. And again, it's not that you didn't earn it, but I just wanted to start these ones fresh this week. So starting today and going through the rest of the week, you can earn the perfect attendance badge, committed. And then scribe is take notes daily and shows Josiah or sends a picture. So if you're taking notes and if you show me at the end of the lesson, or if you send it to me later, if you need to miss class and you send me a picture of your notes. You can just text it to me, and I'll get that, and I will give you your scribe badge also. And then after that, I've got badges made up for our assignments. And I did go ahead and fill this in for now. So our first mastery test assignment was sequence arithmetic sequences in series. And then after that, we did geometric sequences in series. And I've got Anaya down. I've got Brooke down. Levi's earned geometric. Robel's not here, but he earned both. And Savannah, high five, dude. You got both. And Tatiana's not here, but she's got both, and so forth. So I just updated it this morning. So if I missed one, and Xavier, good job. You've got arithmetic sequences in series. If I missed one, forgive me. And if you send me a message, I'll double check. My plan was to update this twice weekly. So maybe on like Wednesdays and Fridays, I'll update it. And I'll share it out maybe twice a week as well. So we'll start class by just doing a quick update and looking to see who's caught up and who's filled in more badges. Um, I would like to see everybody have all of them filled in. All you got to do is join Remind, try answering questions in class, whether it's verbally or in the chat, um, have perfect attendance, and then also take notes. And again, I've talked to some of you last week about like getting paper from the school. So all you got to do is come down to the school, tell your teacher or tell me, and I will get you paper, pencil, and a calculator if you want it. So you can take notes at home. Oh, the code for Remind. You know what? It's in the email. Let me see if I can find it real quick here. Okay, so here's the Remind instructions. If you want, go ahead and just check this out right now. So if you text on your phone this code to this phone number, it should automatically join you to the Math 1 class. The code is the @ BE44CK. That's your specific class. And here's the phone number you're sending it to, 81010, 81010. Here's a link, but I don't think I want to put this in our Zoom call. You would need it in your phones. So go ahead and write me an email or write me a Google chat message, or just take this information down and try it on your phone, and you should be able to join right away. You don't have to download the app. I know some of you have, and that's awesome. It should work as just texting. So you can text to me and then get my announcements as a text. That way you don't have to have a new app on your phone. Thanks for asking, Xavier, about how to add Remind. And if anyone else is having trouble with it, just let me know. I want to get you in there, and you can earn your first badge totally free. Um, any questions right now about the badge board or about Remind.com? Tira, no questions? Awesome. Xavier, love it. There we go. Good job, Xavier. Thank you. All right. I'll probably announce this every class this week just to make sure that students who are here tomorrow and Wednesday all have this info as well. All right. Now, with that, I think let's get started on some actual math. Okay. So this is our third lesson in Unit 6, or third like mastery test lesson. It's called Translations and Transformations. It's a little different than well, it's very different from what we've been doing. The good news is that we've been working with transformations and translations. For those of you who were with me last fall, we started these concepts in a different way. So when we were moving our functions around the screen by multiplying numbers or by adding or subtracting numbers, we've gotten a head start on this information already. Now, for this lesson, we're going to examine three basic parent graphs or parent functions. And here's what those look like. So make sure to copy these down. Okay. There's three different ones. We're going to go in this order. This one's called a quadratic function. And here's the basic shape. The shape is called a parabola. It's a weird word. Maybe it's the first time you've heard it. Parabola. I'll write it larger, sorry. Parabola. And it looks kind of like a bowl or a U. It comes from a quadratic function. The parent graph of it looks just like this. I know there's no numbers on my graph, but it goes right through the origin. And then it curves up on the right and curves up on the left. Parabola, that's the shape of it. And this is the parent function. So we're going to, after we look at these three parent functions, then we're going to look at how to transform them, how to move them across the graph, basically, with numbers. Okay, the next one is called the cubic. Cubic. And this one's interesting. This one is it's kind of like the parabola, but we took the left side and flipped it down, reflected it across the x-axis almost. So it almost looks like the same bowl on the left, but it starts off in the negative zone and then is climbing up, 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 and then turns a little bit and then continues going up. And this is called the cubic. And the last one we're going to work with is actually the very first function we ever worked with, and it's the linear. So here's our three parent graphs. And the linear is just a straight line. It goes through the origin. The slope of it is up 1 over 1. So it's like a perfect diagonal in our graph. Now I want to show you the actual functions for these, but don't worry about the functions for now. We're just going to look at how to do the transformations. So the parabola or the quadratic, this is y equals x squared. The cubic is y equals x to the third power. And then the linear is just the most basic you could get. It's y equals x. And like I said earlier, that we've been working with transformations already, just not in this way. And so the work we've done with transformations in the past will apply to today. So that's hopefully good news. So anything you can remember about transformations, I'm sure will start to kick in and you'll remember some of what we've done before, looking at these three different graphs. Okay, any questions on this before I move on to the new screen? Make sure that you have a sketch made of these three graphs. I want you to be able to remember these shapes and their names. So parabola, cubic, and linear, and then what their basic shape is when we graph those. All right, no one's asking questions. Let me really quick, and I'm sorry about this. I'm going to really quick double check that I'm recording for our Google class. Yes, okay, good. Okay, so translate just means to move the function. And transform means to stretch it or shrink it. So for example, translate is like if I had the parabola and then I wanted to move it 2 units to the right. then our original going through the origin like this, like our picture was on the last page, well, then it moves over 2 to the right. All points are going over 2. 1, 2. So our new version, let me change my color, is the exact same shape, but we've just adjusted the whole thing over 2 units rightward. Shape stays the same, but it moves up or down, or left or right. Now, when we transform it, though, when we transform it, we're taking the original and we're stretching it or shrinking it. So again, if this was my original parabola going right through the origin, same shape as before, but then I wanted to stretch it vertically. So imagine if I took the original graph and kind of like pulled it up and down, all those points go a little higher or lower than when they were before. Let's see what that might look like. We can pull it up and it gets stretched out skinnier. Or we might shrink where we take the vertical and we can kind of like smash up and down. So it gets compressed. That's another word for shrink is compress it. And here's a compression of it in purple. Original's yellow. And then if we smash this thing, it might look more bowl shaped, more wide. Instead of like skinnier, it gets kind of smashed outwards, wider. So see how all my parabolas there, yellow, purple, and red, are all the same U shape, but if yellow is kind of like our baseline, our starting, our parent graph, where all the rest come from, red is like stretched out skinnier, and purple is compressed, smashed downward from top and bottom. Kind of like if it was in a, what would be an analogy? Is there anything in the real world that smashes from top and bottom? Can you think of something? If you've ever seen Star Wars, they do a horizontal compression in the old Star Wars movie. When they're in the trash room, there's some people trapped in like a garbage room, basically, and the walls smash in. Well, what I'm talking about is doing a vertical smash, kind of like a sandwich. If you stacked a bunch of things between two breads and then you smashed it down to keep it flat, I do that sometimes, then everything gets a little smashed outwards, kind of like my purple one there. So we'll look at how to do this in just a sec. So here's a horizontal compression idea, and then vertical on the right, vertical compression. Okay, so now I want to look at how to do the transformations for all three types. Let's go back really quick. We're going to look at all three of these, parabola, then the cubic, and then the linear. Okay, let me get this out of the way. Okay, so here's an example, and we'll use like a real graph with some real numbers. Um, So, where does this thing live? Well, how can we find it? Here's a couple ideas. Where does this actual function, f of x equals x squared, that's the parabola function. I've given you the basic shape of it already, but let's see where it actually is supposed to live. So you can plug it into Desmos. That's our free online graphing calculator to see exactly what that looks like. Also, if you're doing it by hand, you can plug in values and make a table. Plug in x values and get out your y or f of x values. Let's practice that together right now. Get out f of x. Remember, f of x just means y. Okay, so whenever we see f of x, you can change that in your mind to y. Here's what I mean. So let's make a table. I'm going to change to yellow because purple seems a little dark. Let's plug in 0. So plug in 0 for x. Okay, so that's 0 squared. Well, what happens when you do 0 times 0? Can anyone do that for me in your calculator and tell me what you get? What's 0 squared?
0.
0. Thanks, Anaya. So that's where the point 0, 0 is coming from. Let's put that on our graph. Okay, maybe red's better for the contrast. Here we go. 0, 0, right in the middle. So it's going through the very center of the graph. Plug in 1. So x squared is going to be 1 squared. 1 times 1 is 1. So far, this looks like a straight line. That's weird. Plug in 2. 2 squared is 4. Now it's changing. So x is 2, y or f of x is 4. So that's over 2, up 4. And this is where that bowl shape is starting to form. It's not a straight line. It's a bowl like this. And just for, let's see what it goes, looks like a little higher. 3, plugging in 3. 3 squared is 9. So over 3, up 9 right here. And there's the right side. Now, what happens when we plug in some negatives? So let's plug in -1. So y is -1 squared. Okay, remember, now some of our math rules have to come into play. Oh, I see some chats. I'm going to look at that in just a sec. Negative times a negative makes positive. So if you square negative numbers, they're going to become positive. So here's what's happening mathematically. Negative times a negative, 1 times 1 is positive 1. So if you plug in -1 to this function, we get out positive 1. So over left 1, up 1. And that's why we get this nice bowl shape. On the left side of our graph, it matches the right side of the graph. Let me check out the chat. Oh, Tira and Savannah. Sorry, you guys were on top of it. Thank you for answering that first question earlier, along with Anaya. If we plug in -2, -2 squared, well, that's 2 times 2, and negative times negative, positive 4. So -2 comma 4 is on our graph also. Now, I'm doing this because I wanted you to get practice and a reminder on how to graph a function. This function is x squared, but we're also going to work with those other two. So let's move on. If we did -3, we would also have a positive 9. So it's like a mirror image on the left and on the right. I know mine's a little shaky, right, my drawing, but if you graph it in Desmos, you'll see the same thing I have, except it'll be clean and won't be, a little off. So what we're going to look at is how do we translate this thing and move it right or move it left or up or down. Right. Okay, translate the parabola. So here's 2 examples. And this is what it looks like in our formula when we do a translation. So to move it horizontally, remember what we did last fall. If our rule is inside, see how this says f of parentheses? But instead of just f of x, it's x plus 5. So hopefully this will start to sound familiar from last fall. Inside parentheses, it says x plus 5. Then that's our clue that it's horizontal and it's opposite of what it looks like. So instead of going 5 to the right, this is my first thought, When I see plus 5, I think, oh, I'm going to move it 5 positive, right? Just because it says positive 5. It's actually opposite of what it looks like, and we're going to go 5 units leftwards. So if you were given this instead of x squared, but x plus 5 squared, see how that whole thing was changed with x plus 5? Then that's going to be 5 units in the left direction. Same parabola shape, but it's been pulled 5 left. Goes 5 left or in the negative direction. And if we see x minus 5, well, I first look at minus 5 and I would think, okay, that's like downward or leftward, right? Because minus. But if it's in the parentheses, it goes horizontal and it's opposite of what it looks like. Sorry, I'm trying to write fast and I'm writing poorly. Horizontal. So this would actually move 5 units to the right. This takes the same shape, the parent graph, and goes 5 units right. So whatever this number is, minus 5 or plus 5 or plus 10, minus 10, whatever it is, if it's in the parentheses, it's that number and it's opposite direction of what it looks like. So we move 5 to the positive if it says negative. Now, why is it opposite? Why do we do opposite when it's inside the parentheses? If you try taking the formula, let's look at x minus 5. I'm going to come back to this. Let's do it right here. Y equals x minus 5 squared. I want to make a quick table for this, like we did for the more plain version, x squared by itself. So I plug in 0, and this time I've got to do some math before I square. So 0 minus 5 squared. Okay, 0 minus 5 is negative 5. And here's my negative 5 squared, so that's negative times a negative. So we get a positive 25. Let's do 1 and 2 and 3 also. So now I'm going to plug in x is 1. 1 minus 5 squared. 1 taken away 5 is a negative 4. Negative 4 squared is 16. Two minus 5, negative 3. Negative 3 squared is positive 9. Positive 9. Plug in 3. 3 minus 5 is negative 2. Okay, they're getting smaller, right? It's kind of going downward. Negative 2 times negative 2 gives us positive 4. See how these numbers are decreasing. What about plugging in 4 and 5? 4 minus 5 gives me negative 1, but I'm squaring it, and then that becomes positive 1. And then last up is 5 itself. 5 minus 5. You know this is 0, right? 0 squared is 0. And now this same pattern, 16, 9, 4, 1, 0, let's go back to our parent graph table earlier. Right here. 1, 4, 9. 1, 4, 9. 149 in the table. 149. We didn't go farther than that, but if we had gone plugged in more numbers for x, we would have seen next 16 and we would have seen next 25. So on the other side of the zero, this is where things reflect. So if we plug in 6, we should get a 1. Let's try it. I'm going to do the math on the right side. 6 minus 5 squared. So 6 minus 5 is 1 squared. 1 times 1 is 1. Oops. And if you do 7, 7 minus 5 is 2. 2 squared is 4. So we see kind of a pattern of reflection on the left and on the right of that 0. When we minus 5 inside the parentheses, it's taking the original graph and all those outputs, but shifting everything over 5 units. And it's weird that it's opposite of what it looks like, but it's because of the minus, and then it's the squaring afterwards. So that's why for all of our transformations we did last fall and what we see today, whenever our rule that we're working with is inside the parentheses, it's going to affect the horizontal and its opposite sign of what it looks like. So here's our 2 examples again to go back to that. We don't have to make a table for every problem, but I just wanted to show you what happens with the actual like outputs when you plug in numbers using these different translations. Okay, we can also do a vertical translation. So here's what that looks like. What looks different from our parent graph on top, this is the parent graph, to the different translations we see below, the +2 or the -2, it's outside the parentheses. So if your change, your +2 or +5, -2, -5, whatever the number, the change is, if that's outside the parentheses, that means it's a vertical translation. There it is, vertical. So this is going to be dragging it up or pushing it down that many units. And then the other thing to keep in mind is we do this change at face value. We do the change what it looks like. So it's not opposite. It's exactly what it looks like. Changes as it appears. Not opposite. So for on the left graph, f of x plus 2, this is going to be the parent graph. I'm going to put the parent in here in red. And then it's like taking that and lifting it up 2 units. So here's the actual transformation. Same exact shape, but it's been lifted up 2 units. So here's my y equals x squared, and then here's the y equals x squared plus 2. On the right, it's -2. So this is, I'm going to put the parent in there again. Parent graph is like our starting original. So this is y equals x squared. And if you were given f of x minus 2, it's taking this original guy and pushing it down 2 units. So it's supposed to be the same shape, but down 2 units. All right, I feel like when I planned this lesson, it was a little different than how it's happening. So before I move on, I would like to see thumbs, a self-assessment from you on how you're feeling so far on the last few pages I've been talking about. So can you just really quick show me your thumb? Thumbs up means you're feeling terrific. Thumb sideways is you're doing okay, but more work is needed. And thumbs down means you're not feeling great at all about this topic. So go ahead and turn on your camera and show me your thumb if you can. Tira, I appreciate your feedback. You don't have to. I don't want you guys to feel pressured to like give me a thumbs up. I just want to know how you're feeling. If you want to chat me instead, that's fine. So I appreciate Tira and Anaya both let me know how they're feeling so far. Can I hear from all of you? Brooke and Victor, Robel and Xavier and Savannah? Thanks, Savannah. I appreciate you telling me. If you want to chat me, that's cool. Brooke, appreciate that. And Savannah, too. Thank you. Victor and Xavier, you guys still there? Can you chat me how you're feeling so far about today's lesson?
Good.
Thanks, Robel and Xavier. Okay. Alrighty, guys. Let's. So far, what we've looked at. I appreciate you guys giving me the feedback. So far, all we've looked at is the parabola shape, the quadratic. That's this one here. Y equals x squared, or f of x equals x squared. So this is the parabola shape. And then we did horizontal changes, and then we did vertical changes. So the main takeaway is if the rule, the +5 or -5 or any number, plus or minus, if that's in the parentheses, it's horizontal and you do the opposite of what it looks like. If it's outside the parentheses, it's vertical and you do it exactly what it looks like. If you ever are sitting there doing a math problem on some test with me at another school, at college, whatever, I want to encourage you to make a table. Try taking the formula, like this one, for instance, x squared minus 2. And if you're like, shoot, I don't know what this looks like, and you don't have a graphing calculator, what can you do? You can make a table. I know there's a lot to remember, but don't give up. If the f of x, that just means y. So you can do some numbers for input. You just make these up because every x number should be somewhere on our graph. So you can plug in 0 and then do the numbers around it, like 1, 2, 3, and -1, -2, -3. Plug those into your formula, simplify, and then write your outputs. And then these are your x's and y's. The outputs are the y's. All right. So now let's look at the cubic. So just as a reminder, this one, I better make a table so I make it properly with you guys. Um, we'll do a couple points. Let's do 0. So if I plug in 0 and it's x to the third power, 0 to the third power, well, that's 0 times 0 times 0, so it's still 0. And we see that point right in the center. It's on our graph. Let's do 1 and -1. So if I plug in a -1 into this function for x, -1 times itself 3 times. I'll write that out. 1 times 1 times 1 is just 1. But negative times a negative cancels, and there's still a negative. So this time, our negatives are retained. They stay. They're not canceled out like they were with the parabola. So plugging in -1 gives me -1. So here's my next point. When x is -1, y is -1. And when x is 1, 1 times 1 times 1, well, that's 1. So here's that point. So here's the beginning of that shape taking hold. Let's do a +2 and -2. +2, 2 times 2 times 2, 8. So over 2, up 8. Okay, so see, this guy moves up faster than the parabola. Okay, and I'm just going to go from there. And then on the left side, we would get a -8. -2 times -2 times -2. That's 2. That's -2 to the third power. And that gives us -8. Down here, over 2 left, down 8. Now again, this is just our parent graph, but I wanted you to see plugging in numbers, what that looks like. So now to do the transformations and translations on this thing. Just like the last rules, they apply to the cubic. The function's different though. It's x to the third power, but that means we're going to have this shape instead of the bowl shape, okay? Now I'm sorry, it looks like I did here we go, horizontals. Here we go, horizontals first. So we know it's this shape, and look at these equations below. X plus 5 to the third power. This is like the translation or the transformation right here. Plus 5. So I want you to visualize the original cubic, but we're translating it plus 5. My mind says, oh, it's plus 5. We should move it to the right. But if it's in the parentheses, what's the rule? We do it opposite. If it's in the parentheses, it's a left, right, and it's opposite. So instead of, let's put in our original. Here's our parent graph, the cubic shape, but it moves 5 units negative. So 1, 2, 3, 4, 5. So it's like taking the original and then just dragging it over this much. Let me label those so it's clear. Here's our parent and here's our translation. The x plus 5 to the third. And someone in the chat, correct here. Good. It would be negative. It's moving in the negative x direction. That number. So this example was 5, so it's over here at negative 5. Now, our second example, it says x minus 5. It's in the parentheses. We do the opposite. So this time, again, I'm going to put our parent graph. But it's minus 5 in our rule, right? So that means we're going to go 5 to the right, to the positive. Let me label that. Y is equal to x minus 5 cubed. Good question or clarification. I can't stress this enough. When the change you're seeing, the plus or minus number is in the parentheses, do the opposite of what it looks like. In the parentheses means do opposite. So if it says positive, we go negative. If it says negative, you go positive. And if it's in the parentheses, it's a horizontal move, not up and down, horizontal. Okay. I know it's almost time to go. I thought I would get through this all today, but I'm running late today, so forgive me. Let's do the last one, and we're going to review this tomorrow, and then we're going to do an activity tomorrow to practice this yourselves. Okay, I should have built that into today, so I'm sorry. More practice from you guys is always better instead of me talking. But let's finish this one up. So here's the vertical for cubics. Okay, so we're still using x to the third, but now I want to move it up and down. So look at those equations below. This time my plus 2 or minus 2 is outside of the parentheses. So that's your cue that we're moving vertically, not horizontally. Again, here's our parent graph. Y is equal to x to the third power. If this says x to the third plus 2, I'm moving up 2 units. So it's the same shape, but dragged up to positive 2. And if it says minus 2, then we move down. When it's outside the parentheses, we do it at face value. And it's a vertical move. I'm going to make an activity for us tonight to practice these same translations in Desmos. So that way you'll quickly be comparing these functions to each other. And it won't just be me talking. Any questions right now on the cubic function? We did the horizontal rules back here, and then we did the vertical.
No questions.
Okay, thanks for letting me know. Anyone else? Okay. So the last up for today was supposed to be linear, and it's the same rules as what we've already been doing. What changes each, thanks Savannah, what changes each time is what the function looks like the parent base function. Uh, we've done x squared, and then we did x cubed, and now I'm kind of stepping backwards to do just plain old x. Linear, this is our easiest. I'm saving the best for last. So linear has a slope of up 1 over 1. So it's like a perfect diagonal. I'm going to skip our table for this for now. If we wanted to make a table, make your inputs. Ugh, I'm moving too fast and not thinking straight. So make your inputs and then plug it in and see what you get for your output. Linear is just a straight diagonal line, up 1 over 1, up 1 over 1. So, but the same vertical or horizontal translation rules apply. So if this was my up 1 over 1, my y equals x, and I see it says, oh, it's x plus 5, it's in the parentheses. F of x plus 5, it's inside those parentheses. That means it's horizontal, and we do opposite of what it looks like. So instead of moving plus 5, we're going to move negative 5 on our horizontal axis, on the x-axis. So the same line would appear crossing over at negative 5 instead of at 0. Y equals x plus 5. Now you might be wondering, well, there's no parentheses on this part of our equation. And you're right. So some interesting things are happening with the linear function. It still is a horizontal translation, but they also kind of count as vertical translations. It just depends on how it's being framed. Uh, let's look at the next one. Here again is our parent graph, up 1 over 1, backwards 1, down 1, like that. And it says x minus 5. It's inside the parentheses, so I move 5 to the right for the translation. And if you wanted to verify this, make a table. But you're using this function, not the regular old x. You're using x minus 5. So let's try it real quick. I plug in 0 for x. 0 minus 5 is negative 5. So at 0 comma negative 5, I should have a point on my translated line. So left or right 0, so straight down, and there's that spot, negative 5. And then the vertical rules. I think I'm going to actually stop there. I'm sorry for not finishing this, but tomorrow we're going to practice the same lesson. We're not going to start anything new yet. We'll do a quick review. We'll do a group hands-on, well, digital hands-on activity so you can get better practice. And then we'll see if we can get the mastery test done as a group as well tomorrow. That's the goal. So
And which mastery test would it be?
it's called this translations and transformations. So if you feel up to it, go ahead and try it today. It's not due today because I didn't even get through all the stuff I wanted to show you. Okay. But this is the name, translations and transformations.
Okay.
Thanks for asking, Tara. Let's see. Let me just quickly mark down who is here. I think I lost one of you already. Anaya, Brooke, and Robel. Thank you, guys. There you are. And Savannah's here, and Tira's here, and Victor and Xavier. No Levi. Oh, there's Tira. There you are. No Anthony. No Tatiana. No Philmon. Okay. If anyone wants to stay on and ask questions, you're welcome to stay. Otherwise, you are free to go for the day. And
I
thank
just
you.
have one question.
Yes.
So for the activity or for homework tonight, it's just gonna be doing the activity on Desmos.
Oh,
The
I don't have any. Xavier, thank you. You have a good day. I don't have a homework for you guys. I wanted to give you the mastery test today, but I want to